Good morning, everyone. My name is Kevin Burns. I'm the mayor of Geneva, Illinois, and chairperson of the Metropolitan Mayor's Caucus Energy Committee, Environment Committee and Energy Subcommittee. It's my pleasure to welcome you to another beautiful Tuesday morning on the Environmental Committee for today's discussion regarding geothermal energy. Geothermal energy is probably the lesser known of the renewable energy sources. It is a clean, homegrown source of energy available virtually 24 hours a day, 365 days a year. And we talk about reliability. This is the consummate reliability energy source. It has been flowing continuously. Now, we know this from the guy who drinks from the Schiller Park fountain for 4.5 billion years since the Earth was formed. Geothermal energy systems are quiet, low profile, and so low profile, in fact, that we don't even see them. Geothermal systems are installed like underground wells, and geothermal heat pumps that operate inside buildings don't look much different than other heating and cooling systems. And we know this in Geneva in particular because we have a library that is energized via geothermal, so it's pretty cool. Our first panelist and speaker today is a good friend of ours, John Freitag. He's the executive director of the Geothermal Alliance of Geothermal Alliance, and he's going to educate us and inform us about Illinois Geothermal 101. The Geothermal Alliance of Illinois is the state trade association for and was instrumental in the startup of this organization in 2008. Forgive me for the errors there. John is a 32-year plus veteran of the electric utility industry. He retired from the Illinois Electric Cooperative in 2017. He calls Springfield home, where his home has had geothermal heating and cooling, check this out, since 1999. And he also has a solar rooftop PV system at his home. Not to mention, folks, cool artwork from his 5-year-old granddaughters on the wall behind him. John is going to be joined by Marta Moni, who manages group buy programs for Midwest Renewable Energy Association, or MREA, and she connects communities with resources to use their collective buying power to save on the total cost of going solar or geothermal. Ladies and gentlemen, please say hello to John and Marta.
Good morning. I think I'm going to be first. Thank you.
Thank you.
Do you see my slides, Cheryl?
Yes.
Yes, looks good.
Okay. So by mention of disclosure, I should say that, I have been retired just 6 years from the utility industry. I was instrumental in the startup of the Geothermal Alliance of Illinois back in 2008, but the technology's been around a long time. I have spent probably over half of my life in buildings that were heated and cooled with geothermal systems. And as was mentioned, I've had geothermal in my own home since 1999, just chugging away really well. I'll show you some pictures of that in a moment. And I've had solar on my home for between 9 and 10 years now. So my home is about as good as a house that was built in 1961 can be from an energy perspective without tearing it down and starting over again. It's pretty good for what it is. So there it is. So today is kind of a slimmed down Geothermal 101. I've done this presentation many times. I've changed it a little bit for you all today, but hopefully you'll learn a little bit about how geothermal systems work today. And here's the agenda for today. I won't read all these slides, but we'll give you a good overview. And I think that Edith has a couple of poll questions. And the first one is the one that really should get us going. And that's just to ask the group collectively what your knowledge is about geothermal heating and cooling. That will tell us a little something. And Edith, when you see the results, if you can just jump in and interrupt me here anywhere you want. But it looks like we need a fair amount or want a fair amount of rudimentary information, at least half of the participants maybe.
I think it's just the speakers that are hitting very knowledgeable.
Yeah, I see 38% here to learn. And then the second choice is almost 19%. So that's over half. Okay. All right. So here we are. Let's push on. So quick overview of how geothermal systems work. And that's what we'll get today. I like to always start with this slide because this slide tells me a lot. This slide tells me it's heating season because she's wearing a sweater. And it also tells me that they're in a very comfortable house because they're all barefoot. And if you don't have comfort in your home or your office building or whatever facilities being taken care of by a geothermal system, you don't really have anything. So you have to have comfort. And I can tell you that these systems are the most comfortable heating and cooling systems, heating and cooling technology available today. And one of the reasons is because you have long run times. And I like to describe geothermal systems as riding a bicycle downhill. Riding a bicycle downhill, you're coasting most of the time, and it's really easy. And that's what a geothermal system is. And I'll explain why as we go along. So geothermal's called many things. In Illinois, we belabored this years ago. We just decided to go with what everybody called it, and that was geothermal, just geothermal. So that's what that's how we refer to it. Many parts of the country, you'll see ground source heat pump or GSHP. That's pretty common. We just call them geothermal systems in Illinois. Geothermal is renewable energy. I think it's really renewable energy and energy efficiency, but it's renewable energy. If you remember anything from today, just remember that there's no fossil fuels used with most geothermal systems. We're merely taking the ground's natural heating and cooling ability, and we're using electricity to pump water and blow air and move that energy from the ground to the facility that we're trying to condition. So we pump water and we blow air, and more on this in a minute. We know that the Earth is a vast solar collector. I've had solar on my roof for about 9.5 years now, and I can tell you on the grayest, dreariest days of the year, my solar system is still making some energy. Not a lot on those dreary days in November, but a little bit. And that energy, 365 days a year, is hitting the Earth as well, and it's putting that energy, that heat, if you would, into the Earth. And so the Earth is a giant solar collector, and we're just taking advantage of that energy and using it and moving it, pumping water and blowing air. So we know the Earth is a source of heat in the winter. We use geothermal heat pumps to transfer that heat, and it's a great place to reject heat in the summer. And that's what cooling is. It's really just rejecting heat, much like a refrigerator. If you put your hand at the bottom, at the back of a refrigerator, you feel heat coming out. That's what a geothermal system is doing. It's rejecting that heat into the Earth. And it uses typical systems. The vast majority of systems used sealed underground piping to move that energy, that heat to the Earth in the summertime and to take heat out of the Earth in the wintertime. This is a really important slide. I want you to look at this. Where I am in Springfield, Illinois, our Earth temperatures are typically about 54 to 55 degrees. Probably in northern Illinois, in the Chicagoland region, I'm going to guess about 52 degrees. But I can tell you that my incoming water temperatures always are between 54 and 55 degrees. I'm about 8 feet from my geothermal system, my indoor unit right now. You probably can't hear it, but I'm very close to it. And if I walked over to my flow center right now, it's going to tell me that my incoming water temperatures are somewhere in the low 50s. We've had a little bit of heating going on today. So this is an important slide. Why is this important that we're in the 50s. Well, we're right in the sweet spot. So if you think about this with common sense and logic, look in southern Florida or southern Texas. Your ground temperatures there are very warm. And what are you doing in that part of the country? You're air conditioning almost year round. So you're dumping heat into the ground all the time. And the ground is already much warmer, 20 degrees warmer at least than our part of the world. And then conversely, if you're in northern Minnesota, places like that, you see that the ground is much cooler. And what are you doing there? Most of the year, you're heating, you're taking heat out of the ground, but the ground's already colder. So in the Midwest, we bounce back and forth between heating season and cooling season, and we're right in the sweet spot because we've got temperatures that are very consistent in the 50s. That's why geothermal technology works so well in the heart of the US, right where we are. This is an important slide as well. If I said that I'd give you $5 if you gave me $1, would you do it? Of course you would. So for every dollar of energy that you buy from the electric utility, in most cases ComEd, what do you get? You get $5 worth or $5+ worth of energy, because remember, we're not burning any fossil fuels to make heating and cooling in our homes and businesses. We're just moving it. 3 to 5 kilowatt hours or dollars, if you would, of that energy is renewable energy, and we're just pumping water and blowing air to move that energy. Now, people think, somebody mentioned 1999 when I put my geothermal system in. Actually, I was pretty late to the game, because if you look at this magazine, this Life magazine from 1948, it had an article on something called the fireless furnace. And to a great extent, these systems from the late 40s, early 50s were the earliest geothermal systems. Now, they were pretty crude compared to today, and they had to learn the hard way that traditional metal, copper, steel, etc., piping in the ground just didn't work, because that piping got eaten up by the earth and the rocks. It just didn't work. But they did learn that this technology does work. And so there was actually an article in Life magazine in 1948 on the fireless furnace. Now, most everybody on the call today has heard the term heat pump. We all know what heat pumps are. Most people, when they think of heat pumps, would think of an air source heat pump. That's the unit that sits outside on a piece of concrete that looks almost identical to an air conditioner system. And what that heat pump is doing is it's taking heat out of the air. Even on a day like today, it's probably in the 40s in Springfield here today, and it'll be in the 40s in the Chicago region. But it will find heat in that air. Geothermal works much the same way, except geothermal systems find the heat from the ground. And the ground is consistent on a year-round basis. So I just simply ask you to use common sense here. What's a more efficient exchange? To take heat out of 0-degree air or -10-degree air, or 50 to 52-degree earth temperatures? Well, it's pretty obvious. And then conversely, in air conditioning mode, what's a better, more efficient exchange? To dump heat into 50-degree ground temperatures, or to try to dump heat into 95-degree humid air outside? It's pretty obvious. And that's the efficiency of geothermal systems. This actually is my home. I mentioned that my geosystem's about 8 feet away from me, and there it is. It looks on the left, it looks much like a conventional furnace would look in a home, except you see the piping and the flow center. You see that little piece of red there on the right? That's my flow center. That's the pump that pumps the fluid through the earth loops. And my earth loops are in the front yard of my house, right in front of that green bush there between the green and red one, coming out to the bottom of the slide. That's where my earth loops are, my loop field. And I have 3 175-foot loops, and they look almost exactly like this, except this is a scaled down model. So from here to here, 175 feet, 3 sets of loops just like this, of 1.25 inch pipe in the ground. Fluid circulates through that. And that's my fuel tank, if you would. That's where my heating and cooling comes from the earth. Okay, these next 2 slides are really important ones because they describe how geothermal works. So almost every geothermal system has 4 important circuits. Everyone has 3, most have 4, especially for residential systems. The first one's the distribution circuit. That, for most homes, is your ductwork. For homes and businesses with radiant heat systems, that's the piping that has fluid that circulates through the home or the building. But for most systems, it's the ductwork, okay? The second circuit is that it is contained within the unit, and that's the refrigerant circuit. So you remember the picture on the previous slide of my unit that's 8 feet away from where I'm sitting right now? That's the refrigerant circuit. And that circuit simply takes that energy that's flowing through the closed loop system, takes about, in heating mode, about 6 or 7 degrees out of that water, sends it on a reverse trip back down to the earth, and then it multiplies or expands that heating through a refrigerant circuit and makes heat for the home. Reverses itself in the summer to provide air conditioning. It's basically just working in reverse, and it's rejecting that heat into the ground. And then we've got the ground loop circuit. In most homes or businesses, this is on a closed loop field. Again, just like this, using pipe that is just like this. This is an actual piece of the pipe that's in the earth, 1.25 inch HDPE pipe, and that you can see how thick it is. And so the fluid circulates through that pipe to and from the geothermal unit itself. And then the 4th circuit is on most residential systems, but not all commercial systems. Sometimes it just doesn't make sense, but it provides the hot water circuit, or the desuperheater can provide up to 100% of hot water needs. And this is important because hot water is a major energy expense for most homes and businesses, some more than others. But in every geothermal system has the ability to supplement hot water needs, if not make all the hot water needs. Now, this is also an important slide because it's important to remember that all of these circuits, these 4 circuits, are all sealed and closed from the other. In other words, the refrigerant that's within my geo unit doesn't intermingle or mix with the fluid that's in my closed loop field. And it doesn't, and neither of those intermingle with the desuperheater that's supplementing my hot water needs. It's important that all the circuits work together and cooperate with one another, but they don't transfer any fluids or any air between themselves. They merely work together. I mentioned that heating water is the 2nd largest user of energy in the home, sometimes up to as much as 20%. And businesses can be, depending on what they are, can be a really significant user of domestic hot water. And so heating water is a free byproduct of the geo system. I know in my own home, and my system is not the highest end system of the market right now, but it's pretty good. I've had my current unit in my home for about 5 years. I changed out my mechanical system about 5 years ago, and my system makes nearly 100% of my hot water needs in my home, but there are just 2 of us living in our house right now. So pretty darn good. Okay, we rate geothermal systems in 2 ways, okay? In cooling mode, we rate geothermal in terms of EER, and EER stands for energy efficiency ratio. Now, most of you have probably heard of SEER or SEER. That stands for seasonal energy efficiency ratio. Why don't we use SEER for geothermal? We don't use SEER for geothermal for one reason. Underground knows It knows no season. There is no season underground. It's the same year round. Remember, we're right in the sweet spot. So we use energy efficiency ratio. And then for heating, we rate on COP, or coefficient of performance. And that's a complicated term, but the higher the number on both, either EER or COP, is the higher energy efficiency rating. And some of those numbers are just really incredible efficiency, up to 600% efficiency. So this really shows.
John?
Yes,
Sorry to
ma'am.
interrupt. We have lost your slides.
You have?
Yes, we have.
That's no good. Did you just lose them?
Minute or two ago.
Yeah, but we do have the artwork still, which is nice.
We still have the artwork and it's still fascinating, but yeah, the pictures are
Oh,
gone.
there we go. There we
How
go.
about now? I don't know what happened, but anyway, so we're back to cooling efficiency. Thank you, Edith. You can see the slides now.
Yes.
Yes, we can.
Good. So on cooling efficiency, you see the dark green bar there. This is the newest technology. These systems are up to 600% efficient. Remember, they're not burning any fossil fuels to make any cooling or heating. Heating's on the next slide. They're just pumping water and blowing air and using the Earth's natural energy. And you see, by comparison, a typical old school air conditioner or heat pump, maybe an older one, back, down at the yellow bar. I mean, there's really no comparison here, and it's an unfair comparison. My system in my own home would probably be more like the green bar, somewhere between the lime green bar, somewhere between that one and the dark green bar. Still pretty darn good. And then in heating mode is where geothermal really shines. That COP is above 5.0. The newest systems, the brand new systems, are at 6.0 or close to it. And then you see on the other end of the spectrum, that would be your old school, really old school gas furnace, probably an 80% efficient gas furnace or gas boiler, natural gas or propane. So there's really no comparison here. And then you see in terms of heating cost, this is a mid-range geothermal system, and compared to the gas system, and you see heating costs, and everything is more efficient with geothermal, even the operation of the fan and total costs, heating hot water, just, the savings are just really good. Typically, energy costs, if you're looking purely at dollars and cents, heating and cooling costs are typically cut in half with geothermal. Okay, now let's talk a little bit about the loops. I'm going to go through this pretty quickly. There are two general types of loops. That's closed loop system or an open loop system. In Illinois, the vast majority of systems are closed loop systems. I'll explain why in a minute. Most of the closed loop systems are vertically drilled systems, like the one in my front yard. There is the possibility of horizontal and pond loops as well, and we'll show some slides with all that. This is what a vertical loop field looks like. Again, remember this. This is what's in my front yard. I have 3 175 footers. These loops can be as deep as, I've heard of 800 footers. There are some 800 footers in the Chicagoland region, and commercial systems up to 500 feet deep is fairly common. Typically in a residential system, 150 to 200 feet is very, very common. Most drill rigs are set up that do residential systems for 200 footers. So that's the vertical loop field. This is what installation might look like. This is a rural home. This is like a conversion, a retrofit operation. This is what it might look like in new construction. This is actually house is 4 or 5 miles from where I live. And I used to work with this guy. He put geothermal in his house. They're still building it there. This is how many people it takes to put in the loop field. That's my feeble attempt at humor for the day. Some of you who have maybe seen this presentation or something similar to it before are groaning right now. We used to do these training sessions. So these are HVAC contractors. These are people who put the inside of the system in, and they're learning about loop field installation here. And we used to do these trainings more often. Need to do them again. This is what the piping looks like at the bottom of the borehole. U-bend. This is what a borehole typically looks like. A real common one would be a 5-inch borehole that's drilled to the prescribed depth. Again, mine in my front yard, 175 feet deep. When the drill hits the bottom of the prescribed depth, the piping is inserted into the borehole, and then typically right away, that borehole is grouted with bentonite grout. And why is that important? That's important for 2 reasons. Number one, makes the system much more efficient. How efficient would it be if you just had air in that borehole? Wouldn't be very efficient at all. You wouldn't have a very good heat exchange. Or if you just had sand or something like that dumped into the borehole, it wouldn't be very efficient. And so the bentonite grout ensures really high efficiency and heat transfer into the ground, number one. And then number two, probably even more importantly, is it ensures that there's no groundwater contamination. So grouting is done for 2 reasons: for safety reasons for our groundwater tables, and number 2, for heat transfer. A second way of putting in a loop field is with horizontal boring. This is becoming more common, and so you're probably familiar with horizontal boring machines like the one in the upper left there. You see them alongside roads, putting in gas mains, water lines, sewer lines, electric utility lines, etc. And these systems can typically bore up to 200-foot loops, and they're increasingly being used more. They don't tear up yards quite as bad. And this is what that type of installation might look like. You see one loop is in the ground there in the lower left, and they're getting ready, it looks like, to bore the second loop, okay? And then when they're done, that system is headered together underground, typically for residential, and then the piping is brought up through a hole in the floor or the wall of the home and connected to the geosystem. Again, remember the picture of my system looks much like a typical furnace, except it's got 2 pipes connected to it, one bringing fluid in, one taking fluid back to the loop field. These systems can also be put in the ground horizontally, typically at depths of 5 to 8 feet in the ground. It works much the same way, needs a little more pipe in the ground for them to work, but these systems are all across Illinois and horizontal systems. This is what it might look like with an open trench system. So you can put different configurations in the ground of piping, all works very well. Then there's a pond loop option for those people who happen to have a pond. There are some of these systems in the Chicagoland region. Typically, the ones that I know of are commercial systems where ponds have been, retention ponds or drainage ponds have been dug on sites, and they use them for a closed loop that's placed at the bottom of the pond. These systems work really well as long as you have a good, consistent pond that never goes dry. These systems can work very nicely. And this is what that might look like. This is a big installation or a big commercial installation. Basically, they put all the piping on racks and then float them out and drop them to the bottom of the pond, which is on the left there. And the systems chug along and work very nicely. 2 important things for every geothermal system. 2 very important things to remember. The first step is always a load calculation. Why is this important? Well, with geothermal systems, you want them to be properly sized. Much more important than with conventional systems. Most people that have a typical forced air gas furnace heating their homes, almost always those gas furnaces are oversized. And that's fine. They still heat fine. You wouldn't want to do that with geothermal. For one thing, they're too expensive to put in oversized systems, number one. And number two, they don't operate properly if they're oversized because they won't provide proper dehumidification. So you want to size the load. In other words, you want to figure out, walking through the home or the business that's going to be conditioned, you want to figure out what the heating and cooling needs are. So that first step is to run a good load with a load calculation software, and that's going room by room and measuring what the heating cooling needs are. And then you take the data that comes from that and you put it into what I call the energy analysis. And every system that's installed by a competent geothermal contractor should have these two things every time. They should run the load of the facility that's being conditioned, and then taking that data and putting it into this energy analysis. And this sheet gives everyone tons of good information, and it's highly, highly accurate. Tells you what the heating load is, the cooling load is, tells you what the system will provide in terms of energy based on your location, hot water needs, etc. These are very, very accurate. Tells you what the estimated savings will be in dollars and cents. Now, you've probably heard somebody, maybe an engineer or architect or just someone who's opinionated, saying, oh, geothermal doesn't work in schools. Geothermal doesn't work in older homes. Geothermal doesn't work in this or that or the other. I like to say that geothermal can work in virtually any application, but some are more obvious and easier than others. So I mentioned that my home was built in 1961. My retrofit of geothermal back in the day was quite a snap. It was very easy. This is a home south of Springfield that was built in the 1860s. You can kind of see it's pretty old. And this system is a really classic geothermal installation, retrofit installation in a historic old home. So you see down in the lower level, that's a water furnace unit. That's the geo unit, the low profile unit. You see the pipes that are connected to it. You see the white box with the black circles sort of off to the left of center. That's the flow center. So that's where the piping's coming in from the outside, one pipe in, one pipe out. And that's the pumping system that's pumping that fluid through the closed loop field. And then you see two water heaters. Two water heaters would be the classic geothermal installation, desuperheater installation. So the small water heater is the preheat tank. So that's a water heater or a tank with no heating elements in it, if you would. And it's just preheating the water. And then the big water heater, the Marathon, I've got one just like it sitting about 5 feet from where I'm at right now, a big Marathon water heater, just like exactly like that one. And then that's the water heater that serves the house. And so when water's used, the water that comes in, instead of being earth temperature or water system temperature, it's hot water coming from the preheat tank. That's the classic geothermal installation. Here's a little information about geothermal costs and incentives. Now, you're going to hear me talk a little bit about group buy programs. These two homes on the right are in Urbana, the Champaign-Urbana area, and both were installs that were done through our group buy program, Geothermal UC. Here's a little bit of information about geothermal costs in the Chicagoland, Northern Illinois region. So this might be just your typical information, gets you in the ballpark of geothermal. This slide is a little bit out of date because the ComEd Geo rebate is now $1,500 a ton. So that 4,000 should really be 6,000. So, a typical cost might be $48,000 for that system, minus 6,000 for the ComEd rebate, if you would. That's 42. And then the net cost after the 30% federal tax credit, that's a tax credit, not a tax rebate, would be the net cost $27,600. My slide is just out of date. I just learned last week about ComEd's geo rebate being increased from $1,000 a ton to $1,500 a ton. So your net cost after that in all those incentives would be roughly $27,000. But every home is different, and every home's needs are different. And so the loop field would look different in every home. Some homes might need an electrical panel upgrade. Some homes would need backup supplemental heat. Some wouldn't. They already have something in place. You'd be putting in new water heaters in some systems, and others you wouldn't. Every home is different. So the system is going to be tailor-made. The best incentive for geothermal now is the same incentive that's available for solar and wind. Okay, it's the 30% federal tax credit. It's in place essentially for the next 10 years. And it's the same exact tax credit, the renewable energy tax credit from the federal government that solar and wind enjoy. And somebody mentioned that at the beginning of the call that that geothermal is less well known. Well, one of the reasons it's less well known is, for all intents and purposes, you don't see it. There's no panels on the roof. You don't have a windmill on a tower on your property. You just have your power plant in the ground like this, where nobody sees it. And that's sort of the beauty and the curse of geothermal. You don't see it, which is nice, but it also doesn't promote itself. I know, having solar in my home for almost 10 years now, everybody wants to talk about my solar system, but my geothermal system has done much more for us over the years than the solar array, and they're both great. Now, we know that renewable energy systems like geothermal will increase home values over time. I'm not going to read all this, but it's pretty obvious, especially as time goes on and people become more conscious and more environmentally conscious. I think the geothermal heating cooling market has only one way to go. And as more people know about geothermal, it will be valued much greater. There are also health and environmental benefits. I think everybody knows this. I like to say, in the residential marketplace, if you would, in the residential space, there's really only one way to reduce global warming or climate change, and that's with a combination, three-part combination of geothermal heating and cooling, weatherization of the home, and solar installation. You put those three together, it is just a great combination. And if we don't take fossil fuels out of the home for heating, we don't do anything about eliminating the emissions from fossil fuels in the homes. It's just plain and simple, and geothermal is the best way to get there. It reduces indoor air pollution. I'm not going to read this slide, but there's been a lot publicized about gas stoves recently. We're not going to get into that debate today, but we know that if you have little forest fires going on all over in your home, burning combustible fuels, we know that we've got indoor air pollution, and that's important to me. I don't have that in my home, and it's been important to me for a long time. So that's getting to be more of an issue. Again, I mentioned that geothermal and solar, I think, are the perfect combination. I like to say that they're a match made in heaven. They work together perfectly, and that's the way to reduce carbon footprint in the residential sector. It just is. It's the best way. I mentioned that Marta is going to talk about the Grow Geo, so I'm not going to. I'm just going to breeze through these. I will say that the Grow Geothermal Chicagoland is going to be the third group buy that I've been involved with in Illinois. The first one was in Urbana. That was the first one, to the best of my knowledge, in the world. It's just starting its third year. I don't know of any other geothermal group buys anywhere in the world. There might be some, but I don't know of them. And then a second one just got started in December in northwestern Illinois, out in the Galena area, if you would. And we're on the cusp of starting, with the help of CUB and the Midwest Renewable Energy Association, the third group buy, which I think is going to be a real game changer, because we've got mass with this one in the Chicagoland region. And we'll see how it goes. We haven't started yet. It's going to kick off very soon. Those are my slides. Kevin, back to you.
Thank you very much, John. Appreciate it. And Marta, do you want to jump in and talk about the group buy stuff?
Sure, I would love to
Continue.
round out the conversation. Thank you. Let me just pull up my slides real quick. And thank you for having me. As John did a great job of telling us all about the technology.
Right.
And I would like to now talk to you a little bit about what is this group buy that he keeps mentioning. But before I do that, I'm just going to tell you a little bit about who the MREA is, or the Midwest Renewable Energy Association, who I represent. We are a nonprofit educational organization that was founded in 1990, and we're based out of central Wisconsin. So I'm actually just a little north of you in Milwaukee today. And our mission is to promote renewable energy, energy efficiency, and sustainable living through education and demonstration. So we have a number of programs ranging from workforce development training of renewable energy professionals with our courses on solar PV and small wind, to hosting our annual energy fair in June. And we also offer a lot of customer information through our Grow Solar group buy programs, and now our geothermal group buy programs. So our philosophy is the more renewable energy, the better. And the first step to getting there is through education. And we've talked a lot about, or we've thrown around the word group buy a lot. And I know not everyone is familiar with it. So I'm gonna just give you a quick little introduction on what a group buy program is. So it actually started out in 2009 from NREL, the National Renewable Energy Laboratories, came up with this model where we bring homeowners and small businesses together as a community to purchase solar at a reduced price because we're coming in bulk. So it really helps individuals overcome financial and logistical barriers to going geothermal or solar or into a renewable energy technology by coupling education with the opportunity to invest in this technology. So we competitively select our contractors that are qualified to work with us, and we are lucky enough to have the knowledge and experience of John to help guide us through that process. And then we facilitate these programs, we being the MREA and CUB, with our partners. We facilitate them, but we really rely on community support. So that's what I'm going to talk about in a little bit, because that's what pertains to you. The third key tenet of a group buy is that it's a short amount of time. Putting a deadline on a program like this helps incentivize participation. So the open period, the public facing period of this program will be about 4 to 5 months long, or 4 to 6 months long. And then the fourth key tenet is, of course, customer education. And we do that through our power hour education sessions, where we really go over, as John did, the basics and general 101 of geothermal, but then we get into pricing, rebates, and really talking about what it means for your property to go geothermal. And then finally, we rely on the word of mouth of everyone to help get the word out about this. In surveys that we do of our participants, we know that word of mouth and having a good reputation that precedes us helps us gain more customers. And knowing that the information has come from a third-party nonprofit organization like the MREA and CUB and the Geothermal Alliance of Illinois is important to people rather than it coming from a for-profit installer. And then lastly, we've got these economies of scale, which has been staring you in the face this whole time while I've been talking, which means that the more people that participate, the lower the price is for everyone. So what I want you also to consider as I go through the rest of my slides is that we try to make it as easy for your city, jurisdiction, county, whoever you represent, to participate. Supportive municipalities carry no liability And there are a number of ways that you can get involved. So getting back to really how it works, our group buys are based upon this structured collective activism. So the price starts low in our program, and then it'll decrease at several milestones that we set with our advisory committee. And as you can see, kind of as more people participate, the lower the price is going to be for everyone. And that comes in the form of a rebate at the end of the program. So whether someone signs up first or they sign up last, it doesn't matter. Whatever collective milestone we hit, the price will be lower as a result. So just another way to look at this, if we hit our 50-ton goal, it'll be a $75 per ton rebate sent out to folks, and so on and so forth. You can see kind of how that plays out. And our max goal for the Chicagoland area is 150 tons. So John gave you a typical scenario. Here's another typical scenario, very different prices, starting prices here. Something to note, I mean, the size of the systems will vary in the Chicagoland, and we're still working with installers to hash out what the base price is going to look like. But then you can see how the maximum GROW geothermal rebate is factored in, along with the ComEd rebates and the federal tax credit, and it really drops the final price considerably for participants. And we try to take a holistic approach to education and give everyone, as many options as possible. So we do talk about financing, and the MREA is a member of the Clean Energy Credit Union, which specializes in personal loans for clean energy products. And just by way of participating in the program through the MREA, you are now a member of the Clean Energy Credit Union, and can take advantage of their rates. And they have specific loan products for geothermal heat pumps, as well as solar. So the next steps really for jurisdictions, as I said, is that there are a number of ways to get involved, but the things that I want to, and really that means helping us promote, helping us get the word out, tapping into your networks so we don't have to recreate the wheel there. But as I said, we try to make it easy for you. So we require no contracts, no city or county resolutions unless you would like one. And in that case, we're happy to draft and create one for you, and speak to whomever you would like to help get you on board. Our funding comes from an admin fee that we charge the installers. So there's no monetary investment from your jurisdiction, unless you want to give us a little bit of staff time, again, with helping us promote. And in addition to sharing all this information that we have about geothermal, we can also help you and provide technical assistance. I saw in the chat there are a couple questions about, do you have any case studies on schools, and what would that look like? So we can also help walk you through that process as well. So I know I've droned on for a while, but I'm happy to, oh yes, we have another poll. So now, after you've heard my quick elevator pitch, do you think you'd like geothermal in your community? And if yes, we're more than happy. Here, I'll bring up my contact information and John's as well. Please feel free to reach out to us, and you'll have our contact information, I'm sure, as a follow-up to this call as well. So thank you for your time, and I look forward to speaking with you all more about geothermal in the future.
Marta, thank you very, very much. Edith, do you want to address any of these questions that are queuing up in chat, or do you want to just continue on with?
I am going to let John, I think, respond to
Okay.
if there are any questions in the chat that you want to get to. He's been doing a really good job at answering the technical ones, just so we can
Right.
get through all the speakers.
Okay.
So John, is there anything you particularly want to address that needs a chat or conversation here?
Well, as Marta was talking there, I just tried to reply quickly to as much as I could. There were some good questions about district geothermal, and these are systems that could look a lot of different ways, but what they might look like in new development would be when the streets are being put in for a new neighborhood development, et cetera. The geothermal heating and cooling system would also be put in the ground, and then there would be a common pipe that would serve all the homes or businesses within that system. Just think about how complicated that might be in an older neighborhood where you've already got all kinds of things in the ground and you've got to go under streets and sidewalks, and just imagine what you would hit along the way. That could be pretty complicated, not impossible, but complicated. So much like with doing geothermal and new construction, you've got a clean palette, a clean plate. And so it's much easier to do there. I also mentioned that out in the suburbs, I've been through a number of what I think are really cool installations where geothermal is put essentially under the parking ramp, which is ground level. And then there are multi-levels of condominiums, apartments, multi-family systems above. And that common loop field that's underneath the parking ramp at ground level takes care of all the heating and cooling needs for the entire facility. And those systems work really, really well. And they're tried and true, and they exist in a number of places throughout the greater Chicago region. And in my mind, if you were building that kind of facility, why would anyone in this day and age put in conventional heating and cooling when you can do that with no construction at really low costs? So that's just me. That's the way I look at it. And if anyone wants any information about those types of facilities, I'd be glad to help.
Thank you, John.
The only other question that I'll relay, but I think it's more as a heads up to the other speakers, is there was an inquiry about school case studies, but I think we'll get to that. So just a reminder, John, we might call you back if there's those are unanswered by either Aaron or Joe.
Sure.
Ready to move on to our friend from Park Ridge?
Let's do it.
Okay, ladies and gentlemen, say hello to Dan Coulard from Park Ridge. He's a professional engineer at Element Energy Consulting. There's some pretty cool stuff here about our friend Dan. Not only does he drink funky green juice in the morning, he's on half decaf today, so please be patient with Dan as he goes through his presentation. Someone who walks the Geothermal Talk is our friend Dan. He is at Geothermal Systems at his home in Park Ridge. He's a licensed professional engineer and first started working in the geothermal industry in 2008. Dan has designed and built geothermal systems ranging in size from single-family homes to large district systems for multi-million square foot developments to net zero buildings. He founded Element Energy Consulting in 2013, and he has served on the board of the Geothermal Alliance of Illinois since 2014 and is a past president. In his spare time, this guy is building a 2-seat experimental airplane in his garage, and he's named that airplane Serenity. And I've just identified and notified Park Ridge that he doesn't have the proper permits. So ladies and gentlemen, say hello to Dan.
Thank you for that. Yes, there's a sled hill out here. So if the zombie apocalypse happens, I might just have to roll down and try to take off. But good morning, everybody. Hello. Thank you, Kevin. I was asked to come on and discuss my personal experience for my retrofit of my home. And so I will apologize up front. I wanted to show a picture at least of every step of the way. So I have close to 40 slides. So I apologize in advance if I'm a little fast talker as I flip through those to try to stay in my allotted time. But at the beginning, this is usually what you will see. The rig shows up. That's the first sign of something starting to happen. It is easiest to do the drilling in first and complete all the outside work and move in while your existing HVAC system is still running. And then you do the switch over of basically swapping out your furnaces with heat pumps at the end. So this type of equipment, there's 2 style rigs that I think John had referred to a little bit that do most of the residential geothermal work. This style that showed up at my house is a track mounted rig that can maneuver around and has all the equipment on it to do the drilling. The other style is a truck mounted rig where you'll see all the same equipment on there. It just looks like a dually truck with all this equipment, and then the mast kind of articulates at the back end of it. But very quickly, you will, actually, I apologize if that's in the way, but very quickly, your house, if you're anywhere like mine, I live in Park Ridge, as I think was mentioned, and the density is pretty is heavy, so my yard is not exceptionally large, so it will very quickly get overwhelmed with the equipment. But then they ran the screen around it. There was no way that we were going to get a rig or anything into my backyard, so we decided to put everything in the front yard. And even though my front yard is not exceptionally large, it fit everything just fine. So it was about at this point where my son, I think, was questioning what just happened to his perfectly good slip and slide area. And that is not uncommon for a lot of homeowners to have a moment there when all this equipment comes up, especially as they get going. But it is very temporary, and then you are able to return your home and your front yard back to normal in a pretty quick order. So my system was designed to be 4 holes at 200 feet deep, similar to kind of the sweet spot that John had referred to. We basically chose just a triangle and put 3 boreholes as far away from each other as we could, and the 4th kind of in the middle to keep the spacing away from each other and get the proper spacing of the field. This is a pretty typical shot of the vertical. So you'll notice your front yard or wherever your yard can get pretty messy pretty quick. I promise you it's temporary. They had a 3-man crew at there, and then in the background, I think my neighbor had poked his head over there for a second and was very curious about what's going on. As you can imagine, with the equipment and the rigs and the noise, sometimes you do get some bystanders wondering what's going on. And I think I had to tell a lot of people that no, I was not having flooding issues in my basement. This is something I was choosing to do. You'll see, I'll flip over really quick. Typically they'll dig, or they'll have a box for what's called a mud pit. They just dug one in the middle of my yard and then would move the track rig into the different borehole locations. And then I'll flip back here. You can see they'll put the rig where the borehole is supposed to be, and they'll vertically be drilling. They'll usually cut a little bit of a trench from that location to that mud pit for each hole, and that lets them circulate what's called this mud fluid, mud drilling solution, basically, that helps hydrostatically keep that hole open while it's being drilled, and then most importantly, while it's being looped and grouted. So this is a picture of that HDPE pipe that comes kind of wrapped that John was referring to as well. It's very commonly sized at 3/4 of an inch for residential homes. There's 2 pipes that go into each borehole with the U-bend that he had referred to. This was a 200-foot length. And then there's a shot of a loop to depth. They'll usually order these loops 5 or 10 feet long, just so it doesn't slip into the hole itself if it's been over drilled a few feet, and then they'll come by and clip it here like it is when it's done, just a foot or so above grade, and then they'll proceed to grout the hole. I won't spend too much time talking about the grouting. John, I think, did a great job of explaining the 2 reasons we do. We thermally enhance the hole, and then we protect the groundwater from any kind of surface contamination potential. Each night, my son was very interested to come out and kind of take a look and see all the big equipment, and I think kick the tires and see what was going on. But I think he enjoyed watching the process as well. He was still a little concerned, but I think one of the drillers actually gave him a little tour and let him play with the joystick of the large Tonka trucks, basically, and then he was kind of bought in. Once the vertical is completed. The vertical is basically the drilling, looping, and grouting portion of a geothermal install. They took the same rig, they moved it out into the street for a few minutes, and then they set up to do the horizontal header here. And what they did is they kind of cleaned out their mud pit and they dug it a little deeper to get under the frost line. Typically in this greater Chicago area, it'll be around 5 feet. And on the left here, they didn't even bother moving their other equipment, but you can see the rod right here. They planned out their distance and depth, and they just shot right under their equipment. And then by the time they had hit the now what they're using as a header pit, they were right at the bottom of the pit. And then they just kept on going over to the basement foundation wall of my home. And the reason they did this was so we didn't have to horizontally trench right through the ground right next to that tree in my front yard. So we could save a lot of that root structure. So I appreciated that. Once that came to the foundation wall in my basement, they came inside, they found where it was, and they cored through the wall. They then had the gentleman push the bit about 6-12 inches through the wall, and then connected slightly larger HDPE pipe to that bit, and then pulled it back through and brought it back, pulled it back to what's now the header pit, detached the bit, and then got rid of that. And that is installing header pipe in a very convenient way to my home. Once that's done, you're able to horizontally excavate with a mini X from each borehole location to that header pit. So they had 4 little trenches. And then they take the same size pipe as the boreholes, in this case 3/4. So there's 8 pipes you can see there on the left picture, 2 for each borehole. And then they connect them by fusing, which is virtually just melting this plastic together with specific equipment to each header pipe. So now we have a supply and return system that then pushes the water out and equally breaks up the water basically and distributes it through the 4 boreholes. And it runs all the way down and all the way back up, and either dissipates or consumes a little bit of heat there in the process. So at this point, you have an entire completed outdoor geothermal system kind of put together. They come back inside and they'll attach a flush cart to the header pipes, and they'll flush out all the air, and then they'll flush out any kind of dirt or anything that was that got into any of the pipes during the installation. And then they will pressure test it. So to make sure there's no leaks or anything like that, just double checking all their fuses. And once you have a flushed and pressure tested closed loop system, so a vertical closed loop system, as John mentioned, is going to be the most common in the greater Chicago area based on density of homes. But once that happens, it's time to say goodbye to the main equipment outside. The rig gets out of the way and moves on to the next one, and they will proceed to backfill all the front yard with the mini excavator, and then kind of tamp it down a little bit. So what is there on the left is the temporarily kind of muddy mess. They're able to kind of suck up all that mudding fluid that they had, which is really the more liquidy part, and then you're ready to basically seed your lawn on the right there. So here's a quick shot of my fairly small but typical Park Ridge yard for a 2-story. It's about 20 by 40 first floor, second floor home with a little bit of bump out on the first floor in the back, built in 1963. So nothing extraordinarily exciting, but works just well for that. And once that grass seed grew on the front yard, you can't tell it's there. So moving to the inside, we chose 2 heat pumps for my system. My previous system was a furnace in the basement serving the first floor, and a horizontal furnace in the attic serving the second floor. So this is a water to air heat pump. It's a 2-stage, nothing incredibly special about it, but it's got a part and full load. This is a 3-ton unit that gets connected back to ductwork. So typically with existing natural gas forced air homes with a air conditioner sitting outside, you'll have existing ductwork that you just reconnect to in the same locations that your furnaces were. This is the split that I selected, a 2-ton split for the attic unit. This keeps the water down in the basement instead of dealing with any kind of freeze protection things for my attic, since it wasn't insulated. And then you run, and the noise. So the compressor is in this unit. And then I apologize, I don't have a picture of what's effectively the air handler in the attic, but that furnace just gets swapped with an air handler, and it's effectively a fan, a heat exchanger, and a control board. And this unit serves that unit with a refrigerant line set. So once I saw that unit, I just wanted to kind of clean up what was going to eventually be my utility room here over in the corner. So I just built that little angle iron shelf there on the right that they could stack it on. The contractor then mounts the flow center there on the wall, and that's where the circulating pumps that will pump the water basically from the heat pumps through the boreholes goes. And then once that's there, they can pop the pumps onto the bottom of the flow center and do all the interior piping. So the piping just goes from where the pipe comes in to your home and then to the heat pumps. So that is a shot of a finished water to air heat pump. So connected to the ductwork with the piping, and then the de-superheater that John mentioned are in here, and these two pipes. This is a shot of the split unit, and then now you can see the refrigerant line set that heads up to my attic. And then here is my hot water system. So I won't spend too much time on this, but it is very common, as John suggested as well, to do this at the same time. My kitchen appliances were already electric. So then when I converted my HVAC to electric, I went ahead and did the same thing with my water system. The one on the right is the air source heat pump that I purchased at the same time. And the one on the left was my old gas water heater that I just effectively turned into a storage tank. So got rid of the gas line and got rid of the vent that's no longer needed, so I'm not combusting anything. And those tube lines from the unit that serves my first floor connects into that preheat tank and then provides me with free hot water in the cooling months. So that's a shot of a finished product of what you see when you convert to Geo. The outside gives you virtually nothing to look at. And if you don't know that you're looking at Geo, a lot of times you won't even realize that these things aren't furnaces. But that is the end. And I will say that kids do enjoy these large, loud Tonka trunks that they see in their front yard as well.
So what's your son's name?
Landon. So he was 5 at this time. So that was 7 years ago.
Oh my Lord. So from beginning to end, installing the geothermal took how long?
So they started, the outside work probably took a little over a week. You know,
Okay.
it's not abnormal to do a borehole a day kind of thing. And then, you know, the tying together takes a day or two, and then the cleanup, stuff like that. And then the inside work, you know, it was maybe a week, but at that point, then it's just that was just one guy that was doing the majority of the inside work. So it was done in late February, I believe, in 2016.
Nice. Okay.
Yeah.
Kevin, this
Yes.
is John. I might address that. So I will say, every location and every geothermal system, I've been answering stuff in the chat, and
Right.
everyone is different and everyone's
course.
unique. But in general, it is typically easier to drill in central Illinois than northern Illinois, geology wise.
Mhm.
So most of my experience is central Illinois related. So a typical installation of a geosystem in central Illinois would be 1 day's drilling outside for your typical loop field. If it's a big loop field or you run into issues, maybe 2 days of drilling. 1 day for the headering. Remember, that's the part Dan spent some time on, where you're connecting the system to the piping that goes in the house. And then typically for an average installation, 1 day inside. So kind of 3 distinct different projects there that tie it all together. And the folks who typically do the inside work would be different from the folks who do the outside work. Now, Northern Illinois, the drilling takes a little longer typically, but the inside work is pretty much the same. As you agree with that, Dan?
Yep, and really it's because you hit rock here sooner is typically what it is. They hit rock at 65 feet at my home, and then the balance 135 was in rock.
What percentage of the time was primarily Landon's fault?
All of the time past 3 o'clock in the afternoon. But once he got back from school, all the drillers stopped paying attention to what they were doing.
That's good to hear. Any other questions you want to address in chat? Edith, what do you think? Or should we move forward?
I think let's get through all the speakers, and then if we have time, John's doing a great job in answering questions. Sorry if we, I hope we get to them, but let's go ahead with.
We're going to talk about geothermal installation, which, as all of you know, or actually I did not know this, so this is fascinating to me. It's regulated and permitted by the county public health officials. And we have 2 county public health officials with us this morning. Joining us from Cook County and their Department of Public Health is Joe Durzak. Joe is the Private Sewage Disposal and Water Program Manager in Cook County. He's worked for Cook County for over 7 years of his 19-year career in the environmental health profession. Joe is nationally accredited as a registered environmental health specialist with the National Environmental Health Association and is licensed in Illinois as an environmental health practitioner. Now, for those of you who are unaware, Joe keeps the water data records of the county's famous Fountain of Youth, which is found in Schiller Park Woods. And he says that the water tastes pretty good. For those of you who are from Chicagoland and have seen these stories before, that allegedly the Fountain of Youth exists in Schiller Park Woods. Evidence of that is our next speaker, who is actually 245 years old. Please welcome Mr. Durzak.
Hello, thank you for that introduction. Thank you for inviting me here today to speak.
You look great for being a quarter of 1,000 years old, not bad.
I do my best. That water is really quite tasty. For those of you who have not tried well water, the Fountain of Youth well is found on Irving Park, just west of Cumberland in the Schiller Woods. And you may have to wait a little bit because there is usually a line.
Amazing.
So today I'm going to go over closed loop wells, also known as geothermal wells, permitting, inspections, and more here at Cook County. They're a little different than other certified health department counties in that we do not have an ordinance. We just follow state code and law. And so always check with your county health department to see how they want things done. But for urban Cook County, all of Cook County for that matter, I'm the guy. Let's get into it. So here at CCDPH, we have a lot of different programs. You may know us from tanning inspections, tattoo parlor inspections, West Nile virus grants and permitting. And in my program, I handle private sewage disposal, water wells. I also help businesses with their Legionella exposure risk and management planning.
Joe, not to interrupt, but could you just share your slides again? It looks like they're not sharing.
Oh, they're not sharing. Okay, sorry.
And if you have any tattooing slides, please share those as well, since you referenced. There we go.
Here we go. Can you see that now?
Perfect.
All right. So in this presentation, I'm going to go over the application process, what we review, aspects of the installation, and partnership with municipalities and building departments, what we can do to help each other, and maybe some tips towards installing these closed loop well systems. In 2022, we've permitted about 13 installations. It is a state permit. It is required that every site that installs or modifies a closed loop well geothermal system be permitted. And here at Cook County, we issue those permits as the state agent. An application can be found on the website at idph.gov. It's on the screen, but if you Google it, it'll get you there. Typically, it's the contractor that sends that to us. But as a tip, if you're not sure that you want to go with a particular contractor, yes, they have to sign page 2. But if the client pays for it and turns it in, the client or the permit is bound to the client. Whereas if the contractor submits it and sends it to us, it's bound to the contractor. So if the contractor changes, you have to get a new permit. So that's our little heads up about that. The other thing is we need a complete diagram, and the fee is $100 per borehole. First 10 are part of that $100, and then after that it's $10 more. Here's a typical residential diagram. So for municipalities, really we're looking for existing sanitary waste line, where that is located, relationship to the building, where the existing water service is in relationship to the boreholes. And the circled red corner on the left, you'll see the location of the boreholes. That's really important for us to review. Typically, it's the contractor installing these geothermal boreholes that will provide this to us and for my review. And then once it's approved, on the bottom right corner, you'll see some signs of a stamp. My approved plans are always stamped. So as a municipality, if you're reviewing these things, please make sure that you get a stamped copy of the approved diagram. Now for non-residential installations, it's a bit more complicated. A lot of planning should go into this ahead of a project. As John had mentioned, some of these in Cook County go underneath a parking garage, and we've seen that. The Obama Library has an enormous well field, which is going to be going, I believe, under a large parking structure. So before sites build out, sometimes they do a test borehole to see what the site conditions are and the rate of heat exchange that for the formations that they're getting into. And so initially we may get one permit for that test hole, and then the contractor will come back and get a modified / construction permit for the rest of the field. So on this example, it's a proposed medical building that was being planned out. And again, sanitary is shown on here, storm sewer, and the water lines. We need to know where those are located, and then the approximate planned borehole locations as well. And many times these will have a detailed drawing in part of those plans. Again, when I approve it, it'll have a stamp on there. The date from the time a plan is stamped and the permit's approved, it's good for 1 year. After that time, it expires. This is state code. I can't extend it. You have to apply for a new permit. And this is kind of what the application looks like. It is the application from IDPH. This is what we use here in Cook County. An approved permit will be signed off by me, given a date, given a permit number. The contractor will take that to the municipality, and we really do need municipalities to take a look and make sure they have this approved permit from us. Because we've had instances where geothermal contractors come in and they're like, oh, no, you know, we're just going to start going. Here's your HVAC permit, but there is that state component as well. So please make sure that they submit this to you as well. That way, you know, we looked at separation distances to the boreholes and that things are protected for that aquifer. And then our authority is that basically we're going to be looking at the boreholes, the grouting, the actual drilling. Sometimes the aquifers are the main thing we're looking at, and it is our policy to look at every construction site. After installation, as part of installation, we're going to do an inspection. There'll be an inspection form. The contractor, after inspection, will submit a drill log for each borehole. There will be a follow-up with us and the HVAC contractor on the coolant fluid that is used, because that's part of state code. And then we keep records for at least 5 years. Beyond that, it varies per county what they do, but here at Cook County, we keep it for 5 years. One quick note is that state code didn't come into effect until 2013. So anything before 2013 really wasn't permitted. We have no records. And then we are asking that villages and towns help us maintain this. And we work a lot with the contractors. They're supposed to tell us when they start drilling, and we coordinate with them for inspections. But if you see something, please give me a call or let us know. And as a village, a village officer can always stop a job. We always defer to a village and give final authorization to the village. And then things where we can help villages and you can help us is basically looking for that permit signed off. If you want information from us, let us know who to contact. We can send on our approval paperwork directly to a village official, or if it's a HOA, just, you know, let me know where to send it. And if you want us to send on final paperwork, just let me know. It's not usually something we do. We usually give it to the contractor, inspect the contractor to pass it on, but please just reach out to us. And then here in Cook County, we have one inspector for all of Cook County, Stan Gazeski. And then I do all the permitting, program questions, and I'm Stan's backup. This is our contact information. So I'll pass it on.
Joe, thank you very much. And closer to my neck of the woods, we have our friend Aaron Rauscher, the Environmental Health Supervisor at Kane County Health Department. Aaron is also a licensed environmental health practitioner. Aaron, thanks for being with us this morning. We look forward to your comments.
Great, thank you very much. I'll go ahead and share my screen. Okay, can everybody view it?
There we go. Looks good.
Okay, so again, I'm Erin Rauscher. I complete all the well and septic permit reviews for King County Health Department. I am a environmental health supervisor. And just a quick overview of what King County Environmental Health Services does. We do all the well and septic system program. We do food inspections, non-community wells. We're involved with the lead program, tanning facilities, vector, daycares, property maintenance. And then I'm also heavily involved with reviewing zoning petitions for new businesses, residential, for any changes that might have to go through a zoning board of appeal. And a little bit more background on King County Health Department. We are a nationally accredited health department. We did reapply for reaccreditation back in 2019 and did get approved. And our status will be for another 5 years to be nationally accredited. We followed also the Illinois Department of Public Health well code and our local ordinance for closed loop or geothermal wells. We are a heavily populated private well county. Over 60% of King County is still served by private water wells.
You know, Aaron, I did not know that. That's a fascinating statistic.
Yes, we do have a lot. This is including non-community and private. And then we do have numerous communities in our county that are still considered unsewered communities. So they do not have any access to public sewer utilities. So they are completely all on septic systems. Just going over some of our current and past closed loop well projects. We currently only have one permit issued right now for 2023, and it is in Dundee Middle School, West Dundee. They are doing a 90 boreholes for a closed loop well project. In 2022, we issued 2 closed loop well projects. One we had for a church and one was for a private residence. In past years, we had a large planned subdivision unit called Saracen Farms located out in Hampshire. It was a community that was based on sustainable and green practices, where homes were required to have geothermal wells installed for heating and cooling of the properties. And we haven't had too many more permits go there, but we do have a few residences put up in that subdivision. What our main role is in geothermal well permitting is very similar to Cook County's. We do require permit and review the permit application. We are looking for on the plan, we have residential and commercial examples, unincorporated versus incorporated. That on your plan, we're looking for where our public utilities are located. If it is a residence that's unincorporated, are they on a septic system or on public sewers? We need to see all of that put on the plan. We do an inspection, site visits, and then what parts do we inspect? We look at while the well is being installed and then post-installation record requirements. Our permitting process is also very similar. We need complete applications turned in. So a fully filled out permit application with a well contractor signing. We use exactly the same application that Cook County does. It's a state of Illinois issued permit. We look for, again, our site diagram showing all setbacks, borehole locations, if there are any other existing wells on the property, septic systems, public utilities. All the payments are made to King County Health Department. We also charge a very similar structure where we charge $100 for the first 10 wells, and then each additional geothermal well is $10. We also charge a one-time inspection fee of $180 for each new well permit. I apologize that this isn't done bigger, but this is an example. This is actually part of Dundee Middle School's project. In this area, this is actually where all the boreholes are going. And that's just another, again, it's hard to see based on the scan because it's a large site plan and it's shrunk down the page, but you can kind of see this is the main area where all these wells are going in on this property. I also just wanted to bring up what we're looking for when I'm talking about setbacks. This is directly from the Illinois well code, and there's a difference between a drilled well and a closed loop well. We're looking for setbacks. So on these site plans, this is what state code is requirement. So a closed loop well would need to be 50 feet from a septic tank, and then 50 feet from an aerobic treatment plant, 75 feet if it's for a farm property. If there's any animal confinement lots, we're looking for those separation distances. So there are some situations where the closed loop well can be closer. It's dependent on what type of cooling mechanisms used. So if we're using like USP, food grade propylene glycol, we can have a closed loop well closer to another existing water well. So it's dependent on what is the cooling fluid used in the well. And in King County, the health department is the only authority given to issue these permits for a closed loop well, either modification, sealing, or new construction. We primarily communicate with the well driller to schedule any site inspections and timeframes for completion of the project. What we go out and inspect at the site, again, it's not always all in one day because, for example, with Dundee Middle School, we have 90 wells going in. It's going to take about 2 months for them to complete this project. So we'll go on different days to observe either grouting or drilling, or possibly see an entire well go in on that same day. We also check that the materials they use are in compliant with the code when we're on site. And our policy is also to inspect every job site that has a permit issued. After the well is completed, we provide inspection report to the well driller. They are required to submit to us an official drill log. Then what we do with this paperwork, we keep a copy on file, and then we also send a copy to the Illinois State Water Survey of all the completed paperwork. We have records that go back to about 1992 with the King County Health Department, and it's our intention to keep all records. We don't get rid of them after 5 years. We've kept them since 1992 and going forward. Collaboration with municipalities is probably something that we need to look forward in improving on. You always ask when in doubt. If you're not sure if a permit's been issued, you can contact the local health department, especially if there's no permit issued. We do want to put a stop order on that construction until a permit is issued on site. We also confirm with local municipalities and request in writing no objection to issuing closed loop well permits. We do look for your approval as the final approval to issue these permits. And our main thing also going forward is we do leave it up to the well contractors to submit all the final paperwork to the municipalities. But if going forward we need to do that more, we're always willing to send you a copy of our inspection reports and the permits. And I did just recently take some photos again to show you the Dundee Middle School project. This is some of the piping showing here. Again, this is a very large scale project. There's a lot of material involved. This is an actual well being drilled on site. And then this picture to the right, you probably can't see very well, but all these little blue flags is where all the geothermal closed loop wells are going. And then this is to show you one that's been completed. It's not 100% completed, just to show you this one has been put in place in the ground. So, and there's other ones in the distance, but this is just as they're going, this is what they look like until the final project is done. This is my contact information. If you have any questions, this is my phone number and email, and then this is the location of King County where we complete all our well and septic permit reviews.
Aaron, I have one quick question for you. We heard from Joe that he has a huge team of 2 for all of Cook County. How big is your team in King County?
Our team is also a team of 2.
Okay.
We're a small team for the entire county.
Wow. Any questions in the chat, Edith or Cheryl, that we should have Ms. Rauscher address as best she can before we run out of time?
You know, there are many good questions in the chat, mostly technical in nature. I guess I'd allow for Dan or John or Aaron or Joe to address anything that they felt like got left out. I know we're a bit over time, but.
And John mentioned he'll be happy to provide information via direct contact as well. Of course, Aaron shared her contact, Joe and Marta and others. So
I think a lot of the questions at least were attempted. I think somebody had asked something about rules of thumb regarding cost benefit of geothermal versus solar. I think they tend to be separate cost benefits. They have both have their own pros, but like John said, they match really well together. Solar produces electricity, geothermal uses some very efficiently.
Yeah,
that would be another 20-minute discussion to get into that, and I'd be glad to, but that's probably another webinar for another day. I would say that the 2 presenters from the counties did a good job of explaining how the regulation works. There were some questions about that in the chat, and I tried my best to answer them. In general, most counties have followed the state codes. There are, I think, about roughly 15 or 20 counties in the state who have codes that are a little bit different from the state code, and they go in typically a little bit farther. Personally, this is a personal opinion, I think that regulation of geothermal loop fields has been a good thing in general. I don't necessarily agree with all the regulations and all the codes, but I think that in general, it's been a good thing for everyone, and protection of the aquifer is really important. The one thing that in the state codes that I think is rather disappointing is that everybody refers to geothermal loop fields as wells. And the one thing that geothermal loop fields are not, is well. A geothermal loop field is not a well. The aquifer is typically penetrated for a very short amount of time, and then the loop field is inserted in a closed loop system, and the system is grouted. In other words, it's sealed totally. That has so little in common with a water well, or what we know of as a well, but it's what we have. And we're in the state water well code, for better or for worse. So it is what it is.
I say we mount opposition and offer the John Freitag an amendment and change all that. So anything else before we move on, and just announce that April 18th is our next environmental committee meeting. We are likely to talk about either updates to the Soul Smart program, as it were, or environmental, social, and governance, otherwise known as ESG, which of course just made the national news a couple days ago. So April 18th is our next meeting date. Just as a heads up to all of you who regularly attend, I may be en route to Springfield that day. So if I'm not there, you'll enjoy a break. So with that, anything else, Edith?
I'll just offer, because this was a topic of great interest and we're thrilled for that. We did consider how best to manage this topic. So we are planning a follow-up, a site visit, actually. We've been wanting to go to the Village of Countryside, which has a net zero village hall, and they also have a geothermal field. So John has agreed to come there. We'll invite Dan and Joe and Aaron to come as well if they'd like to. So we'll have another chance to continue this conversation and look at the systems in person.
Excellent.
And thank you for all the great questions. I'm really glad for the interest in this topic. And don't forget the group buy that Marta, though she's off the call, is looking for communities that want to learn more about that.
Wonderful. Thanks to all our presenters. Happy first full day of spring. Have a safe Tuesday, and thanks again for joining us.